The activity we'll be looking at today is asking us to analyze a set of data. Sometimes it will be like this in the form of a graph. Other times it will be in the form of a picture, kind of like this one here. And we are asked to essentially become familiar with how does this information here, what does it help us understand about cells that we previously did not understand? We're going to do a couple of these together through watching a video and class discussion. But after we've done a couple of these, you and your group members will be doing one together. So I did want to give you a couple examples. First, we'll do one of a graph and one of an explanation picture. So if you happen to get a graph one, you are able to tackle that one. If you happen to get a picture one, you are able to do that one as well. They will be different than the ones that we do here. There's a total of 5 data sets that we need to look at as a class. This one happens to be data set number 2. And this information, it will be used on future assignments, so you might want to keep distinctions between what is data set 2, what is data set 1, so on and so forth. So the first thing that we should do when we're presented information like this is first read. The first thing we need to do is kind of read. So let's kind of go through the reading. And as we do, we need to kind of annotate it. If there's anything that comes up that we don't understand, we need to identify it and then figure out what it means so that we actually are beginning to understand what it is that we're reading. So starting with the reading, the graph to the right shows a count of normal liver cells versus cancer liver cells. When we say count, what are we talking about when we say count? You should be thinking count like count numbers. We are looking at how many. So we're looking at how many normal liver cells are in a picture compared to how many cancerous liver cells happen to be in the picture. It's telling us that normal liver cells is the lower curve. So normal liver cells, it is the lower curve. And looking at our graph, we can see normal liver cells. We see normal cells here. Cancerous cells are, this line looks like the lines overlap here and then kind of split right here. So this bottom one is where we see the normal ones, and this one that goes up is the cancerous ones. It tells us that these normal liver cells in that graph, they have a relatively stable count at increasing cell density, while cancer cells of the same cell type show an increase at higher cell densities. So we have stable, and when we hear the word stable, we should be thinking not changing. So it's relatively stable, meaning that it's not exactly a straight line, but it's pretty consistent as we are increasing cell density. So let's check out where this shows us this information in this graph. So looking over at a graph, whenever we look at a graph, the first things that we need to do is not look at what's going on here. It's look at what is on our x-axis and look at what is on our y-axis. Those are the very first things that you need to do whenever it is you're looking at a graph. On our x-axis, we're looking at cells per area. This happens to be a unit of measure of area, and that would be density. So we're looking at density here, and we can see that we are looking at densities that are very low and increasing in density of cells. Here we see cell counts. Recall, counts was the how many. So we see how many cells are in a defined unit of area. Area, or density is a measure of how much is in an area. So if we have this box, there's this space. There's a how many. Here's our defined unit of space. There's how many cells are in it. What this is saying is that normal liver cells have stable count, so a stable how many, as density increases. So we see density increasing. We see the amount of cells in that space staying relatively stable. However, when we look at cancerous cells, as density increases, the amount of cells grows exponentially. Many of you described a difference between normal cell division and cancerous cell division previously, as cancer cells grow exponentially. They grow very fast. They multiply quickly. That was one of the many comments I saw that was common on our previous worksheet. And just to clarify what we mean by density, we really kind of mean this. Let's suppose we have this much space. We're looking at how many cells are in this space. If we just have one cell, that would be a low density. If we have a lot of cells, it's in the same area. We are increasing the cell density though. So we're looking at the density cells and how many cells happen to occupy that space. So now that we've kind of talked about what is going on our x-axis and going on our y-axis, let's go back to our reading. It says, from this, it was concluded that populations of cancer cells have lost the ability to function meaning work, so they have lost the ability to work together in a manner that sustains healthy tissue. We talked about healthy tissue. One word that we saw previously was the term apoptosis. And apoptosis means when a cell becomes damaged cells, they die. Apoptosis is cell death when they become damaged. We were comparing previously that normal cells, they go through apoptosis when damaged cells occur. They end up dying. But in cancerous cell division, apoptosis, it does not exist. Damaged cells do not die. Damaged cells continue to make more copies of themselves. And we end up with a growing population of these damaged cells, so on and so forth. Going back to our graph, once again, just to look at it, we can see that the total number of cells, the how many, it kind of stays consistent as density increases, whereas cancerous cells, the total number of cells, they do start to skyrocket as density increases. We're going to be looking at a couple questions that we're going to be discussing together as a class. Number one, what does this graph help us understand about cells? We'll have to answer that. And also, we will be asked to share and discuss evidence that kind of helps support whatever it is that we come up with as a class right here.